All right, welcome to this explainer. Today we're going to challenge some of the most fundamental assumptions you probably have about how applications should store data. I mean, for decades, we've basically been taught to treat our databases like giant variables. We write to them, we update them, and we delete from them. But what if that approach is actually destroying valuable information? What if instead we modeled our data as this indestructible history of facts? Well, that is the core idea behind modeling immutable data. And today we're going to unpack two incredibly powerful architectural patterns from the source material that make this possible: event sourcing and CQRS. Okay, let's dive into this. So here's our quick roadmap for the deep dive today. 1. The trouble with mutable state. 2. Enter event sourcing. 3. CQRS and optimizing for reads. 4. The conference booking example. 5. Advantages and hidden pitfalls. And 6. The illusion of state. All right, let's kick things off with section 1, the trouble with mutable state. We really need to question the standard practice of constantly overwriting our data. Just pause and consider this for a second. What if your database never, ever deleted anything? In traditional database design, if a user changes their mind, or they update their profile, or alter a transaction, what do? We just run an update or a delete command. The old data is wiped out. It's literally gone forever. But think about how accountants have worked for centuries. When a financial transaction happens, an accountant doesn't bust out an eraser and rub out the old balance in their ledger. No way. They write a new line, a strictly append-only entry that describes the money moving. The final account balance is just derived by adding up all those individual transactions. By constantly updating and deleting data in our modern apps, we are essentially taking a giant eraser to our digital ledgers. We lose the entire history of how we actually arrived at the current state. And practically speaking, this makes debugging nearly impossible. And auditing is an absolute nightmare. Because if a software bug corrupts a user's balance and you've just routinely overwritten the old data, you have literally no way to trace exactly when, where, or how that error actually happened. And that brings us to this profoundly brilliant observation made by computer scientists Jim Gray and Andreas Reuter way back in 1992. They said, "There is no fundamental need to keep a database at all. The log contains all the information there is." I want you to really think about the weight of that statement. The only real reason we store the current end of the log state in our tables is just a shortcut for performance. It just makes retrieval faster. The true system of record isn't that final table of current users or current inventory. It's the comprehensive log of every single change that has ever happened to get the system to its present point. So let's put these two paradigms head to head to really solidify this architectural divide. On one side, we have your traditional databases. In this model, you're constantly mutating state. You're overwriting rows, you are replacing the old truth with a new truth, which means, by definition, you are continuously discarding context. But on the other side, we have event sourcing. Here, data is an append-only log of immutable events. You never change them, you never modify them in place, and you certainly never delete them. You only ever append more events to the very end of the log. The traditional model gives you this fragile little snapshot of right now, whereas event sourcing gives you the complete, undeniable story of everything that has ever happened. And that contrast leads us perfectly into our next core concept, which is section 2, enter event sourcing. So event sourcing is defined as using an append-only log of immutable events as your ultimate source of truth. And the absolutely crucial detail here is that every single state change is recorded as a past tense fact. Why past tense? Well, because an event is a permanent record of something that has already happened and you can't change history. We're talking about things like item added to cart, checkout completed, or payment processed. Even if a user later decides they want to cancel a reservation, the fact remains undeniably true that they formerly held a booking. You don't go back and delete the original booking event. Actually, scratch that. You can't. You simply append a brand new booking canceled event to the log. The intent of the user, the sequence of their actions, the exact chronological timeline, it is all preserved forever. But writing to an append-only log introduces a pretty massive operational problem. How on earth do we quickly read or query this data if it's just a giant, endless chronological list of historical events? That takes us to section 3, CQRS, and optimizing for reads. Right? So if our data is stored as a sequential log of, say, millions of past tense events, running a simple query like, "Hey, how many seats are currently available?" would be painfully slow. The system would have to calculate it from scratch by reading the entire history every single time. And this is exactly where CQRS comes in. CQRS stands for Command Query Responsibility Segregation. It is the principle of maintaining completely separate read-optimized representations, which are often called materialized views or projections, that are derived directly from our write-optimized event log. We are fundamentally segregating the responsibility here. We write to the event log super quickly, and then we asynchronously translate those events into different, highly optimized views just for reading. Because our read models are entirely decoupled from our write models, we can scale them independently based on user traffic. It creates incredibly fast, resilient applications. Now, to truly understand how this all works in harmony, let's look at a concrete example from the source material. Moving on to Section 4, the conference booking example. Imagine you are building a system for booking conference tickets. You have your central event log, and then you have your derived views. In that event log, the events are all named in the past tense, right? Conference created, registrations opened, seats reserved, booking canceled. This central log is the absolute, unquestionable source of truth for the entire system. But from that single log, we derive multiple, highly distinct materialized views. For the individual user, we might build a customer booking confirmation view. That could be formatted efficiently as a simple JSON document showing their specific paid amount and assigned seats. But for the conference organizer, we use that exact same event log to build a completely different view, maybe an analytical dashboard charting seats booked over time. The data is written exactly once as a permanent event, but it's seamlessly translated and presented in whatever read-optimized format the application happens to need at that moment. Let's break down the exact life cycle of how data flows through a system like this step by step. Step 1. A user sends a request, which in this architecture we technically call a command. For example, reserve 3 seats. Step 2, the system takes that command and validates it against current business rules, like are there actually enough seats available? Step 3, once it's validated and executed, that command crosses a threshold and becomes an immutable fact. It's recorded permanently in the log in the past tense, seats reserved. A really crucial detail to note here is that a materialized view is not allowed to reject an event. By the time it hits the log, it is a valid, indisputable fact. And finally, step 4, the materialized views, our read models, update asynchronously to reflect this new event. This strict separation means our write throughput can be incredibly high since we're just appending to a file, while the read views just catch up at their own pace. But of course, no architectural pattern is a magic silver bullet, right? We have to thoroughly weigh the trade-offs. Which brings us to Section 5, Advantages and Hidden Pitfalls. The advantages of event sourcing and CQRS are just immense for complex systems. First off, it communicates intent super clearly. Seeing an event named booking canceled tells the developer exactly why something happened. Contrast that with a traditional database log showing a Boolean flag silently changing from true to false, which is completely devoid of context. Second, we get perfectly reversible actions. If an action was taken in error, you don't delete it, you write a compensating event. Like if a user is accidentally charged twice, you don't delete the second charge, you issue a refund processed event, which perfectly maintains your financial paper trail. Third, and perhaps the most powerful feature, reproducible views. If you accidentally deploy a bug in your view maintenance code, you haven't destroyed your actual data. You just fix the code, delete the corrupted materialized view, and literally recompute it from scratch by replaying your immutable event log. It also provides full auditability, which is basically a superpower for regulated industries like finance or healthcare. And finally, it offers incredibly high write throughput because appending to a sequential log is one of the fastest operations a computer can physically perform. But we do have to carefully consider the downsides because they are definitely there. First, handling external data is remarkably tricky. Say an event requires a currency conversion. You can't just fetch the live exchange rate when processing the event. Why? Because if you have to rebuild that view a year later, the live exchange rate will have changed, and your historical data will suddenly be completely out of whack. You actually have to store the exchange rate inside the event at the exact moment it occurs. Second, the fundamental requirement that events are strictly immutable creates a major clash with modern privacy laws, like the GDPR, which grant users the right to erasure. If you legally cannot delete an event containing personal data, what do? Well, a really brilliant common workaround in the industry is called crypto shredding. You encrypt the personal data within the event, and then you simply throw away the decryption key when a deletion is legally requested. The data remains in the log, but it is mathematically unreadable. Finally, reprocessing events requires extreme meticulous care. If you delete your views and replay your event log to rebuild them, you have to ensure your system doesn't accidentally trigger external side effects all over again. I mean, just imagine the absolute panic of a developer realizing they just accidentally re-triggered the system to resend 10,000 booking confirmation emails to users while running a routine database rebuild. You have to design your systems to cleanly suppress those side effects during a replay. Okay, as we wrap up, I want to tie all of these architectural concepts back to a slightly higher level mathematical concept. Section 6, the illusion of state. When you really step back and look at the relationship between the data on your screen and the events underneath, there's a beautiful analogy here for those of you who are mathematically inclined. Mutable state, so the current account balance or the available seats you see on a dashboard, is simply the integral of the event stream over time. It is literally the summation of everything that has occurred. Conversely, the event stream is the derivative of the state by time. It represents the rate and nature of the changes. This means that mutable state and an append-only log of immutable events are not contradictory ideas at all. They are just two sides of the exact same coin. The application state you interact with is really just a momentary snapshot. It's a temporary illusion created by mathematically summing up the comprehensive history of changes. So here is the big question I want to leave you with today. When you sit down to design or build your next application, ask yourself, are you storing the true history of your data or just its final shadow? By adopting event sourcing and CQRS, you preserve the exact, undeniable sequence of facts that shaped your system. You unlock incredible auditability, deep debugging power, and just unmatched architectural flexibility. You stop erasing history with every single update, and you start logging reality. Thank you so much for joining me for this explainer. I really hope this inspires you to look at your data models in a completely new light. Keep learning, and I'll catch you next time.